Annyeonghaseyo, ladies and gentlemen. This is Professor Eric Nelson, and this will be the first of 2 or 3 videos that I'm going to post that will teach you some of the things we need to know in design thinking. Now, this video is all about what is the difference between science and engineering. Now, all of you take science, and your science teachers will do an amazing job of explaining to you what scientists do and how they do it, and probably a little bit of what we've learned from these scientists. But I'd like to take a few moments here and talk about what is engineering, how is that slightly different than science, though they often work together, and since we're also playing a game where some of the villains are mad scientists, let's talk about what is a mad scientist, or perhaps maybe we should really be calling them mad engineers. But again, let's talk about the difference between what is science and what is engineering. Now first, let's talk about what is science. Now in the top left here, you will see a picture of Jane Goodall, an amazing, amazing scientist that I've had the opportunity to meet. Now scientists will go out into the world and make observations. And you can see Jane here making observations about the behavior of chimpanzees. But she would then ask questions like, how is this behavior the same as humans? How is this behavior different than humans? What purpose does this behavior serve? These are questions, and that's what science does. It asks questions about the natural world, and then through hypothesis and experimental design and testing and analysis of the results, we'll then learn perhaps answers to some of the questions we can pose. For instance, one of the questions we might even ask is it possible? And our friend Albert Einstein here once stated that education is not the learning of facts, but the training of the mind to think. And science is a way of approaching problems. It asks questions and then seeks answers to those problems. Now let's spend a little bit of time and answer the question, what is engineering? Well, if science asks questions, engineering solves problems. And that's a big idea I want to put into your head. Whereas science might ask, is it possible? Engineering would ask, is it feasible? Can we actually put that into practice? And let's talk about some famous engineers. In the top right-hand corner here, we have James Watt, who was both a scientist and an engineer, but some of his famous engineering feats includes the development of a practical, usable steam engine. Another great engineering feat and engineer, this fellow, if you haven't already guessed it, is Eiffel. And Eiffel is the man who designed and helped build the Eiffel Tower. This is an act of engineering. And as one more example, and I encourage you to ask your parents about it because you probably don't know, but this is Scotty. And Scotty was the engineer for the TV series Star Trek, which was then remade into 3 other TV series, 4 actually, and one of the reasons why Scotty was Scottish was because some of the first great famous engineers in Western culture included Scotsmen like James Watt. But once again, engineering solves problems. So let's review what we've kind of talked about up to now. Science is concerned with understanding fundamental laws of nature and the behavior of materials and living things, whereas engineering involves the application of science and technology to create useful products and services for the whole community within economic, environmental, and resource constraints. Again, the question for engineering is it feasible? The question of science, is it possible? Science asks questions, Engineering solves problems. Pause the video if you need and review these words. So let's talk about some examples that might help you better understand the previous slide. Now here we have a picture of some scientists. And scientists discover new compounds and investigate their properties. So these scientists might, for instance, discover, these are called nanotubes. They're made from a source material called a buckyball or Buckminster fullerene. And they will discover these nanotubes and will investigate their properties. How strong are they? How flexible are they? Now, engineers will develop new uses and applications of these materials. Can we use these materials to build a space needle? Can we use these materials to make indestructible car bodies? Nanotubes are a new material that engineers are just now looking for applications from batteries to bridges. And so right now, science has discovered these materials and engineers are trying to put them to use. Maybe you will be one of those design engineers who figures out a way to practically use these materials. Let's now talk about electricity as an example. Let's first talk about the science. Well, this is a picture of the U.S. statesman Ben Franklin. And whereas many people know about Ben Franklin, he's on the $100 bill, he was ambassador to both England and France. Many people don't know this until they remember the kite story, but Ben Franklin was an early scientist who investigated the properties of electricity. So scientists discovered different ways to generate and use electricity. Whereas over here, this is an example of an electrical engineer, engineers develop principles into practical components and use these to build power stations and enable the users of electricity to improve the quality of people's lives. So when you see people working on these high voltage power lines, these are engineers, and they are worried about the practical, how do we transfer the electricity from a power station to the outlets at your home or apartment. Again, what is science? Discover electricity. What is engineering? How do we deliver that electricity to people's homes? Now, here is an example that you might even see on a rack. And let's talk about going to the moon. What is the science of going to the moon? And what is the engineering of this same going to the moon? This is a Saturn V rocket blasting off. But what part of this blast off is now engineering? Now, I recommend that you use Schoology to talk about this, start a discussion, but talk it out with your classmates before class. What is the science of going to the moon? And what is the engineering of going to the moon? That will be your rack tomorrow. So let's review very quickly. Mad scientists would ask questions like, how can I kill everyone on Earth? Or what would kill a human? Whereas an engineer would figure out how to build the death ray. So here's a comic. Why did you build a death ray? To take over the world? No. I mean, what mad hypothesis are you testing? Or are you just making mad observations? Look, I'm just trying to take over the world. That's all. You are at least going to leave some of the world as a mad control group. Notice that over here, this person understands that science asks questions and wants to make it testable, whereas engineers try to take that understanding and turn it into a practical application. In this case, we have a death ray. So the sad truth is that most scientists, mad scientists, are actually really just mad engineers. Here's a quick graphic about scientific inquiry and scientific design. It might help you better understand the difference between science and engineering, but here is the big idea I am trying to put into your heads. Science asks questions about nature, and engineers design solutions to a problem. Gosamnida for listening to me, and we look forward to seeing you in class. Bye-bye now.